Okay. So I think there's really no simple way of just getting into it. I think we just got to get into it, which is to say, like, let's jump into Grasshopper and take a look at the interface. I'm going to start sharing my screen and we'll get into it. So one thing I will say is that, in the box folder, I did upload in a new folder called example work, and I upload this folder here called Frank's Grasshopper student work from the GSD. And I think this will be useful for just basically your context. What I mean by that is to see where I came from and how I learned. And so this is the work that I posted in Grasshopper into the box folder. And literally this is the first ever Grasshopper stuff that I've ever worked on when I was a student many years ago. And so you can see basically it's really simple, basic pattern studies, massing studies, things that kind of take the whole idea of Grasshopper, which is to take a simple concept, a simple topology, and iterate against it and do a bunch of different iterations. And so this diagram here shows one example of a workshop that we did early in the curriculum of how to take a simple grid and begin to morph it and turn to this shape here. And then this project that you see here, this was the first board of a studio project that I was working on with the team actually, and we were looking at basically hydroponics and urban agriculture as kind of like a system that we were designing. So, we made a bunch of diagrams and all that fun stuff, but the thing that I wanted to show was literally this diagram right here. This diagram that I made when I was a student. You can see that when I was a student, I made like Illustrator diagrams with arrows and labels and all the things that I criticize you guys for, I was doing when I was a student. So I'm not perfect. Yes, I made, I was making fun of Dustin last week for making the arrows with lines. And here's one example with my arrow and line connecting stuff together. And as you can see, there's a fish on it. So yes, I do stuff like that too. I'm not perfect. All right, fine. All right. You can laugh all you want, but yes. But the whole thing is that, this little diagram right here, this little, agriculture kind of looking patch here, this was done in Grasshopper. And this was sort of, one of the scripts right here. You can see on the upper left here that I put together to do that. And literally, it was as simple as just, making boxes in Grasshopper, then taking the area of those boxes and multiplying it by a certain like cost to kind of get a yield amount. And that's kind of what I thought. Okay, we're gonna propose these plots of land. Is there a yield per square foot in terms of how much lettuce yield, tomato yield, pepper yield, blah blah blah, that you can get from that? And literally, this simple Grasshopper script was the first one that I wrote. And the reason I bring this up is because all you need to learn how to use Grasshopper is something really dumb and simple that you need, like a simple thing that you want to figure out how to do. And that's all it takes for you to get addicted to it. And so my goal for like at least this early stage of the tutorials, just to get you guys hooked and addicted to this concept of Grasshopper work, which is saying like, yeah, you're not going to master it in day one, but if you just understand the basic concepts of it and see the possibilities, you will just use it naturally. And if you just use it naturally, you'll learn. It takes like a year or 2 years to actually fully get into it, and not as like a semester of work. So that's kind of what my hope is. So anyway, I showed you guys some examples of student work just to give you guys context to see where I came from. But with that, can everyone see my Grasshopper thing? Yes. And like I said last time, whenever I do my tutorial now, I minimize your faces so I don't see any of your faces. And that way, when the recording happens, you see the entire screen. So if I ask for like a question, the best way is just to say it, as opposed to like nod your head, because I won't see your head nods. Okay, so the way you have, if you have Grasshopper open, basically, If you don't have it open, basically in Rhino, there is this little launch Grasshopper button right here. And if you click on that, they'll open this window on the side. And I've just simply stuck, the whole Grasshopper interface to the right and the Rhino interface to the left here. One thing is I just gotta find my layers component. I don't know where that went. I'll just go into window. Let's see, where's my layers? There we go. Just want to make sure that's on the side here. So in Grasshopper, obviously, if you use the right mouse button that pans around the interface, if you use a scroll wheel, that will zoom in and out of the interface. If you right click anywhere on the interface, like so, it brings up a little menu, and this will be a handy menu that we'll use many times in the work. There's also, if you use the middle mouse button like this, that brings up a little handy menu wheel as well. Both of these, the middle mouse and the right mouse buttons, are really handy for the work that we do. So just keep in mind that that's kind of the basic interface that we got to work with. So if you haven't used Grasshopper before, just use, start practicing, just getting used to the way you navigate this space. So when you open Grasshopper, you'll see basically it uses a ribbon interface, similar to all programs now, where the top bar has a series of tabs, and each of these tabs has a series of components. So when all these little buttons that you see in Grasshopper, these are called components, right? And basically, components are basically either elements that do some kind of action or elements that hold data. And so whenever I talk about like bring in the move component or bring in the vector component, that's what I mean. It's like these little buttons are called components. Okay. So the first thing that we're going to talk about is the most basic piece of information in Grasshopper, which is a point. And so right here at the top left of the parameter tab is the point component. One thing you can learn to do, basically, it's one thing to just like go to the tab in the top to get to it, but you can also double click anywhere in the space and just search for the component that you want. So let's say you want the point component, just search for point, and then you can bring it instantly like that. This is now how basically I do things, is I just double click in any space and just search for the component that I want to use. And that's the easiest way to do that. But we're going to start with the point as the most basic component. Everything that you see in this tab here, this thing called Params, that is part of the parameter tab. And whenever I say the word parameter, think of the word parameter as kind of like an ingredient in a recipe. There is the recipe itself, which is like the action that you take to like put things together, but then there's actual ingredients within the recipe as well. And that's what a parameter is. That's all you need. Whenever the parameter is a fancy word, but all it is just basically a piece of data that you can adjust and change depending on your project. And that's why it's called parametric design. It's because it's a design where the recipe or the definition is consistent, but the ingredients or the inputs change, and that changes the outcome, right? If you put more pepper in your recipe, it becomes more peppery. But if you put more sugar, like it's the same recipe, but it changes the output a little bit. So that's my metaphor to explain it. So with this point component, I'm going to zoom into it a little bit closer. Basically, these components here, they can host geometry that you draw inside Rhino. So let's draw a point in Rhino. So I'm just going to go to a point, click a point somewhere. I'm going to actually draw the point maybe out here. Okay. So there's a point in a point in Grasshopper right here. So to set that point, basically, it's upside down. You right click on the component, and then there is this thing called set one point. You can also set multiple points. We'll do both of those examples in a second, but let's do one for now. So you click on that, and then you can basically set that point like so. And you see what happens is now the component now has hosted the geometry. So if I select this component in Grasshopper, you'll see that it highlights the preview in Grasshopper, turns like a little green dot. Now, the most powerful thing about Grasshopper is the fact that geometry has data associated with it, has information that's built into it. It has a length, it has a width. In the case of a point, it has a location. It has an X, Y, and Z location. And this is what makes Grasshopper powerful, is that you can take this point here and you can visualize and use the actual information associated with it. And so the most basic information of a point is basically X, Y, and Z. So there is a component in Grasshopper called Deconstruct. So I'm going to type in Deconstruct, and you see right here, there's this thing called Deconstruct, a point into its component parts. So I click on that, and then brings up this, this thing here. So in Grasshopper, it's a visual programming interface, which means you just basically take one component and you connect it to the next one from a left to right orientation. It always moves from left to right, never from the other direction. So that's one way to keep your head straight, is that data always moves in the right direction. And now you've basically taken that point and you now have access to its values of its X, Y, and Z. And you can use those numbers to do anything you want. You can use those numbers to, move it in a certain direction. You can use those numbers to, create, information about it. So let's do a very dumb, simple example. So type in a circle component, and we're going to use the circle component called circle CNR. And then basically what this is asking for is a center point, which is what C is. If you hover over the variables, it tells you what it's asking for, whether it's a point, a normal, or a radius. So if you put in that point as the center point, and then you can put any one of the values, let's say the X value, into the R. Now you see basically if you move this circle around, the bigger you make the X value, which is say the bigger that you move it to the right, the bigger the circle gets. And obviously the further from the X value you get. So basically this is kind of like your 0 line. So now it's going to the negative space here. So it's out negative 200 something. That's what you're trying to basically showing with this, is basically that the number that these numbers here are parameters that you can use to affect geometry. But that's just a really dumb example. A more useful and more practical thing is, let me delete this here, is you just want to take this point here and you just want to know where it is. You want to be able to visualize, say, like, what is the Z, the X or Y value? And in landscape architecture, we care a lot about the Z value, right? We do spot elevations. And so let's say you want to take this point here and you move it around your model. You want to just like know instantaneously what is the elevation of that point. And so what we're going to do is we're going to use a tool called text tag. So if I type in text tag into the search thing, you get this thing here. And this is just a very simple component that labels geometry in Rhino. So L is asking for a location of the tag. So that's literally the point itself. So I bring that in here. And then T is asking for the text to display. So let's bring in the Z value right there. And then basically it's really hard to see. So what you need to do is just right click on this here and make the text size large. And so now if I move this point in the vertical Z direction, you'll see that now it's beginning to visualize the actual elevation of that point. And this in the in landscape architecture is, in my opinion, all like the foundation for all like good modeling. Is you just need good spot elevations. You need to have the ability to like easily draw geometry. Let's create a few more points and set those points. So let's not set multiple points. So I drew 2 more points in Rhino. So we're going to click on this, right click on it, and now we're going to set multiple points. Now we're going to select all of them at once, then hit enter. And now you have multiple points where you can illustrate the spot elevation. So like I was saying, this is the most useful thing that you can get out of Grasshopper, is the ability to extract information and visualize it. Now, if you imagine you're modeling in Rhino, you are modeling with precision. At all times, that point is at that elevation, that point's at that elevation. And likewise with this one here. And so it's just a very useful place to start, is to understand that you can extract information from points like so. Now, one thing that you'll look at is that you're looking at this point here and thinking to yourself, yeah, that's great, Frank, but you know, that number is just like kind of big and unwieldy. It's a little bit long. It is useful, but can it look more like a spot elevation? And the great thing about Grasshopper is there usually is an answer to every question that you're asking. Like, can the way that this is visualized be a little bit more friendly? And so we can do that. So what I'm going to show you guys now is this tool called Format. I'm going to type in Format into the search right here. So we're going to have this thing called Format. And what this allows us to do is allows us to take any input, it's like say a number here, and format it into a specific type of string. A string just basically like a line of text. So I'm going to bring this Z into basically here's how the thing looks. There's going to be a format to the text, which we'll write in a second. Culture, which we don't need to worry about, and then the variables of the format, which is 0 and 1. So we're going to bring in this to the 0 like so. And then what we're going to bring in is a little thing called a panel, right? So in the top of the parameters tab, there's this thing that looks like a yellow square with a scribble on it. That's called a panel. This is kind of like a little notepad that you can bring in, and it's a good tool for, number one, visualizing data. So if I bring in like the Z here, you can actually visualize the actual values of these spot elevations. But also what it does is it allows you to input data as well. You can write information into this. And we're going to write here as a little, into this panel here is a little format logic for how we want this, these spot elevations to be displayed on the screen. So what I mean by that is just follow along here. I'm going to put in a little bracket, the little squiggle bracket you see there. And then I'm going to type in 0 because 0 is the number that, you know, the Z is being input here, 0. And then I'm going to put a colon, right? Basically 0 is, right? And then we're going to do 0 like that. And so, whoops, sorry, period, 0, 0. So basically what that is doing right there is it's taking the number, the input, and it's rounding it out to 2 decimal points, like so. So this goes into F, like so. And then if you plug that T into the new text string there, you see what happens is now that spot elevation has been rounded to 2 decimal points, which for construction purposes is pretty much the only precision you need. You don't need any more than 2 decimal points usually for spot elevations. So that's a nice way you can take that number there and format it to be more landscape architecture friendly, I guess we can put that way. Another thing you can do is you can do more to the string. Let's say you want to annotate this in such a way where, you know, it feels like a spot elevation. Usually in construction documentation sets, there is like a little plus sign indicating the location of spot elevation. So you can put a plus sign into this format here, and you can like adjust that. And then one little fun trick is if you add a bunch of spaces to the format, you can begin to shift that over so that it feels a little bit more centered on that point. So now what we've done essentially was we've created right here a spot elevation tool. One of the simplest tools you can have, but maybe all you want to do is you want to model a project and you just need to know the spot elevation. Voila, you got a spot elevation tool. And as long as you set those points in here, like I did here, you can do that. And now you can work on your design, create your plans, create your walks, and you always know at all times, like, all right, I'm doing something at that spot elevation, that spot elevation, that spot elevation, and if you move things around, they adjust as we go. All right, that was, congratulations, you just wrote your first Grasshopper script if you've been following along. Any questions?
Sorry, I missed what that second node you had, the PXYZ one. What was that node called?
The PXY, oh, this one right here?
Yeah, that one.
That's called Deconstruct.
Deconstruct. Okay, I went right past it.
Yeah.
Okay,
one trick you can do is if you, on your keyboard, I don't know if it's the same for the MacBooks, but I think it should be. If you hold Control and Alt on your keyboard, you see your mouse has a little eye next to it. You can use that to basically click on any component and it has like this little weird, fun little diagram that shows basically, it tells you where it is in the ribbon at all times. So it's like kind of a silly little thing. And also one thing you can do is if you right click on any component, you can click on help and it tells you what it is, gives you details on that. Okay, component 1 is done. So now what we're going to do is we're going to look at another simple component, right? So I'm giving you this information. I'm just going to throw out a question to you all, and hopefully the answer that I'm going to get is the answer I expect. What's another useful way you can model in Rhino and get information? Like what, if you were to model something in Rhino, what kind of information do you wish you had visualized while you were working to help your modeling process?
Slopes.
Slopes is a good one. We'll do that one. What's another one?
Dimensions.
Dimensions, that's a good one. We'll do that too. Look for one more.
Surface area or something like that?
Surface area. That's all you, like when you are putting together drawings for projects, that's what the contractor is asking for. They're asking for how much of it, how big is it, how long is it, how much area is in it, and you need to be able to communicate that kind of information in addition to the spot elevations as easily and effectively as possible. That's kind of what we do, is we communicate complex geometries to contractors, and we do that with numbers, right? So I'll move this up to the top, and let's do a combination of a few things first. In Rhino, I'm going to click on the Polyline tool here, right? And we're just going to draw, imagine you're drawing like, I don't know, the boundary of a park or the boundary of something. I'm going to draw a few arbitrary shapes like so, okay? So you can, if you're following along, you can just draw a few arbitrary shapes as well. Let me go into a top view. Like this. So what we're going to do is in Grasshopper, we're going to bring in these curves that we just drew using a curve component. So double click in the space and just type in curve. And that the curve is a thing that looks like a whirlpool. So bring that in. Let me bring it down here and I'll zoom into it. And I'll do my best whenever I do these Grasshopper tutorials is to not like do this, which is like spin around, zoom in, and do that, because I know that gets disorienting. I'll try to just like leave it. I'll just leave it still. So right click on the curve component. And now we're going to do multiple curves just to do 2 at once. So we do curve 1, curve 2, hit enter. If you ever select a component, you should see it like visualized and turned green in Rhino. If that does not happen, check this bar right here where it controls the visibility. Either it shows nothing, which is this one right here, and then when you select stuff, nothing highlights, or if you choose the red box on the side, it shows it. And then this one in the middle only shows curves and wires. It doesn't show surface geometry. So what we're going to do now is we're going to get area for this. So double click in here and type in area. Oops, sorry. Area. And now if you plug this in here, and as long as the geometry is closed and solid, you will be able to extract the square footage. As long as your model's in feet, you'll get the square footage of both of those curves here. So this is square footage of curve 0, and this is square footage of curve 1. A handy little trick is if you don't know which one's 0 and which one's 1, you can use this component called point list right here. And if you connect the P to any point location, in this case, the centroid of these circles here, or sorry, these polygons here, it allows you to show the actual index number. So this one's 0, that one's 1, like so. So we're going to use that text tag tool once again, text tag. So, and now we're going to utilize that format tab again, format. And now what we're going to do is we're going to take this area value right here. We're going to plug that into 0, and we're going to format that to be, put a little bracket, 0:0.0, and that colon SF for square foot. I'll put a space between this thing here and that SF. Then you plug that into your F format. Then you plug, now you basically do, you take this C, which is the location, the center point of these geometries, put that into your L, then put T in here. And there you go. And the one thing I always recommend you do is as you're writing your scripts to clean up the order of your scripts. Right now, the script is kind of, messy looking. Try your best to arrange the components to always run from left to right. And if you can avoid wires crossing over one another, that helps. Sometimes that's unavoidable, but something just moving it like that just makes it a little bit cleaner. And that's just basic good script writing practice. Is just to make sure that everything has a logical, looks logical on screen. So there you go. And now, let me make this text tag bigger. Now, if I go to these geometries here, oops, and I turn on the vertices for that, as you are adjusting the parameters of the geometry, you see the number now changes as it goes. So again, the whole point of this is that it allows you to design free. It allows you to design more organically and have the output, the critical information that allows you to take the design and evaluate it from a size and scope point of view. That information is always at your fingertips at all times, thanks to things like this. So congratulations, you just wrote script number 2. Now you have a simple tool that allows you to draw any shape. And if you set those shapes in this tool here, it allows you to get the square footage of that shape. This literally, as I showed you in my little example earlier, is how I learned Grasshopper. I just made scripts like this that just told me, I do little areas, little plots that represented certain types of plants in agriculture. And I just wanted to get the square footage of that. And I wanted those numbers to reflect some kind of metric in my design process. Okay, dimensions. All right, so you're drawing these shapes here, and you're saying, okay, well, what's the length of one side? What's the length of one side? We can do that too. There is a tool called Dimension, and we're going to use this tool called Aligned Dimension right here. So if we're following along, that's the one we're using, Aligned Dimension. And what we're going to do is we're going to take all of these squares here, these polygons, and we want to put a little dimension line along each of the sides of it. So to do that, what we need to do is to take each of these polylines here, and we need to extract out each individual face side of it. So there is a tool called Explode, right? Explode, it takes each curve and explodes it into its segments. It's basically the segment between each vertice. So I put Explode right here. If you bring that into, if you bring the curve component and you connect it to the C right here, the curve to explode, that takes the curve and it breaks it into its segments. And so S is the segment, V is the vertice. And so what we're going to want to do is we're going to take these segments and we want to extract the dimension from that. And so the dimension tool, what it's asking for is asking for a start point and end point to the dimension. And so what we need to do is we need to take each of these segments and we need to extract the start and end points of the segment. So now there's a component called endpoints. So I'm going to type in, search for this tool called endpoints right here. extract the endpoints of a curve. So I'm going to use that to get the endpoints of each segment. So I bring the S, which is the segment of the exploded polygons, into there. And so now it looks the same, but basically each of these segments now has a start and endpoint, start and endpoint, start and endpoint. And we can use that now, plug in S to A, first dimension point, E, which is the end of another line, into B, like here. You can see something has happened. Something has happened there. We'll zoom into this in a second. There's an offset from the baseline. So how much do you want this dimension to extend off of that? So right now it's offsetting by a unit of 1. Maybe you want that to be a little bit bigger. So what I'm going to do is to adjust this value here. You can either put in a little panel. I'll just do that. Let's bring in a panel. Actually, I'll do this instead. Instead of using a panel, I'll use another tool that is worth introducing, the number slider. The number slider is every Grasshopper user's favorite parameter tool, because it allows you to have this slider that allows you to like have a dynamic changing value. So you can add a number slider by just clicking this and adding it into your space like so. But an easier way to add a number slider into Grasshopper is to double click into your interface and then just type in a number. The number represents basically the maximum value of that number slider. So I put in 10 and hit enter, you get a number slider from 0 to 10. Another thing you can do, let me delete that, is if you type in 10.0, hit enter, now you get a number slider that has that goes from 0 to 10, but now has the decimal decimal point interval precision with it. And again, you can also do 10.00, and then you get even more precision with that. So just fun little secrets that you can use. So let's take this number slider here. Let's plug into this O. And now you see that this dimension line has offset by a unit of that much. If I zoom into that, let me do this actually. Let me take these. These are kind of huge. Let me take them and I'll just scale them down a little bit, like so. Okay, let me zoom into that. If I zoom into this now, you see what happened is now we've added a little dimension line around each of these lines here. So this is the foundation of layout plans, right? If any of you ever working at a firm in the future, you're going to create a lot of these layout plans. You just need to take geometry and you need to tell the contractor how big is it, how long is it on one side, how long is it on the other side, and then obviously you need to tell them what's the angle between each of these lines too. Another thing you can do is, yep.
Why does it offset like on the inside of the rectangles, but on the outside of the other shape? Is there a way to like change like which side of it offsets the dimension to, or is it?
Yes. Was that Alex? Did you ask that question?
Yes.
Okay. Thank you. Yeah, I can't see your face when you ask questions. I appreciate it whenever you guys ask these good questions, because then I can tell you like things that I probably would miss as I go through this. You basically just need to take these pieces of geometry and you need to flip the orientation. So if I click the geometry in Rhino and type in flip in Rhino, that basically flips the orientation of it. And so that fixes that. And all that means basically is that, when you ever draw, geometry in Rhino, things always have direction. And that's the thing about these computer tools, is that computer tools lack intuition. They don't know which side is up. They don't know what's up, what's down, what's left, what's right. That's where the user, the designer, you, myself, we come into play. We add that human intuition that tells the computer like what is wrong with it. But basically, the tool is flip. The tool is flip. Okay, so we've added that dimension now, and then the last thing that we can do is two last things. You can also change the format of it. Again, right here we have a format tool. So let's do that. So quick thing you could do, you can just like take a panel that you've already written. You can copy and paste it, right? And we can format these dimensions. Let's zoom into a dimension here, just see what happens. And let's do 2 decimal points, and let's add a little foot mark right there. So now you can annotate this in such a way where it's a little bit more, has an actual unit value associated with it. Or if you don't want to have 2 decimal points, you can just do 1. Depends on how much precision you're willing to give up to the contractor. And that's, all in that decimal point right there. So, 2 decimal points for length, for a length component may be too much, but there you go. And then the last one right here is this S right here, size. So let's do this. Take this slider here, copy and paste it. I'm just gonna click on it, Control C, Control V, move it down here, connect that into that. And now you have a dynamic slider that allows you to adjust the dimension of that. So now you can very easily have a dimension tool that you use. You can draw geometry in Rhino. You can change your design, and you don't need to worry about documenting it because it's just documenting itself for you. Keep in mind that also areas only work for planar geometry. So what I mean by that is if I go into a 3D space and you try to move this, if I take one of the vertices and I move it vertically like so, that geometry is no longer planar, and you see that this no longer is able to calculate area. So the area component now turns red, and it says that there is one curve in this set here that's not planar. As long as it's planar, it's okay, it works.
Hey, Frank,
Yeah,
can you do a curve? Can you dimension a curve?
like an arc or a
Yeah.
spline.
Yes, yes.
Yeah, I haven't tried that. Let's find out. Curves are notoriously difficult to annotate, but let's just find out. The answer to the question is I don't know, but I'm just going to draw one. We'll see what happens. So it didn't quite work. In this case, basically, it just grabbed the overextends. I'll look into it, Anna, and I'll see if there's a way to annotate curves. But one thing you can do, if is to just go into the display tab here, and in the dimension drop down here, you can see these are all the built-in dimension tools. I mean, there's this thing called circular dimension. Maybe that's probably what we want to use. But I'll look into that. Maybe that's something I'll look into in the break. But yeah.
I might have missed something, but you have one singular curve that was annotated and the others were not.
So that's all built into what curves you set in the initial curve parameter right here. That was literally step 1 of the whole process. So you said that this, we'll just recap that again. So if you want to set 1, you just click on the curve component, right click on that. And it's depending on if you set one curve or set multiple curves. Does that make sense? So if I choose 1,
Yes.
now it's just doing 1. If I set multiple, you can select 2, you get 2. You can set multiple, you can select all 4, and you get all 4.
Okay, based on selection.
Yeah. If you delete 1, usually happens is that it remembers that you selected it, but it suddenly went missing in Rhino. So it goes orange, just goes, what happened? Did someone get lost? And so if that happens, basically it's just telling you that something happened in Rhino that conflicted with something that's happening in Grasshopper. So you can just undo the deletion in Rhino, and that will fix that.
And how do you remove a connection in Rhino, like a line?
In Grasshopper?
Grasshopper.
Yeah. Okay. Good question. A few things you can do. Let's say, let's just use this one here as an example. You want to disconnect L, right? Just right click on the L and there's this disconnect right there, and that removes it. Another thing you can do is if you want to turn off a component, let's say you want to take this area here, or yeah, and just disable preview. If you select it and right click anywhere in Grasshopper, you can choose this preview off button, right? The thing that looks like a guy with blindfold, looks like he's a hostage. Click on the hostage and that turns off the label, but it's still running in the background. So if you click on anything that's grayed like this, and then turn on the kidnapper, you know, there's a hostage and a kidnapper, there it is. And it's revealed once again. And I apologize for that very dark metaphor, but when I saw the person with the blindfold, I was like, that looks like a hostage. So, but I do not support hostages. FYI. This is all recording. It's all going to go on the YouTube page. So I just want to be very clear.
Yeah.
Yeah.
You mean kidnappers, right?
Yeah.
Yeah.
Okay. Another thing you can do as well is, you know, there's preview on and off, but also what you can do, let's say, you know, you want to stop the calculation of a process. You can click on any component, right click, and you can choose this thing called disable. And that basically what it does is it cuts off, it turns off this component entirely. And you see what happens, that basically that because this is turned off, it shuts off the process of anything that goes downstream to the right of it. So you can, you know, effectively, you know, pause a component by, you know, bottlenecking or ending or killing off, you know, one component midstream, and then you can turn it back on by selecting on it, then choosing enable, like so. That turns it back on. All right. So now you've done a very simple script that allows you to draw geometry. As Anna pointed out, it's only rectangular or angular geometry. We'll get into, because you guys just want everything to be circles and curves. I'll look into the curve question later.
The area should still be accurate for that curve one as well, wouldn't it?
Correct. Yeah. So if I do a curve like so, then set curve, you know, this component doesn't really work at all, but the area, you're correct, it does capture the area of it. So you should be able to draw, you know, your organic geometry and get accurate square footages from that. All right, it's 8:48. What I want to do is I want to do one more. And this, unfortunately, this tutorial is moving a lot slower than I thought. I thought I'd get much farther than just two little components, but I want to answer the question of slope, which I think is, you know, one of the more critical ones that we need to know how to do. So we have spot elevations right here. We have horizontal dimensions and square footages here. Now we want to look at slope. So let's go out here, and I'm going to do this is I'm going to actually utilize these points again, because we can just use those points again. And so we're going to move down in Grasshopper, and you see in Grasshopper, you know, Grasshopper is essentially just a giant sketchbook. You can have like 100 component definitions within one, and it doesn't matter. It's just, you can just, you know, have a bunch of these just laying around in your Grasshopper definition, and it's great, you know. And so there is always, if you ask me, I never work with just one definition at a time. I have like one Grasshopper file that has like 5 definitions in it, and those 5 definitions are doing different things in my Rhino file. So slope, let's go here. I'm going to do this. I'm going to take these elements here, and I'm going to select them all, right click, preview off, and that just turns off the preview of everything. And then we're going to go down here. We're going to bring in another point component thing here. I'm going to right click on that, set multiple points, and we're going to select those points again. Let me zoom to those points. And I'm gonna show you a tool called Polyline. So you double click in here and type in Polyline. What Polyline does is it takes all the points in a list and it connects those points together to create essentially a polyline. So right now, these 3 points are in one list. I connect this in here. It just simply connects them together. And it connects them in the order that they were selected in Rhino. So if I select them again, I right click on this point component and set multiple points. If I do 1, 2, 3, then hit enter. Now the polyline follows that direction, like you said right there. So let's actually do 4 points. Let's add one more point here, and I'm going to set multiple points, and we'll do 1, 2, 3, 4. So, and what we want to do is we want to take this line here, which you can see has like a series of zigzags that are moving uphill, and we want to extract the slope from these. So, pop quiz: what is slope?
Rise over run. Yeah.
Rise over run. Bonus points to, it sounded like Anna said that.
And Sadie.
And Seda, yeah, both of you definitely need bonus points. You're not doing well in class. Good. So rise or run. Rise or run, essentially the vertical change divided by the horizontal change, right? So what we need to do is we need to take each of these curves here. We need to extract that value. What's the vertical change between the start and end point, and what's the horizontal change between the start and end point of this. So how can we do that? Well, first we need to do is we need to take each of these segments and we need to isolate them with from one another, right? We want to be able to judge the slope of this one, and that one independently of one another. And so we're going to, in Grasshopper, I'm going to zoom in here, use the explode tool again, right? To bring out to isolate each of the segments as individual segments. And then we need to take each of the segments here and we need to figure out have some way of calculating the horizontal change and the vertical change. So well, there's a tool on Grasshopper called project. And there's several project tools here, but the one we want is this one right here called project an object onto a plane. Okay. And the reason we want this tool here is in order to get the horizontal length of each of these curves here, we just need to take this curve and we just need to project it so it's flat. And then you basically get the horizontal length of it. And that's it. That's the easiest way, because the horizontal length is not the length of it. It's the length of it in top-down 2D space. And so what we're going to do is this: we're going to take each segment here, and I'm going to extract the endpoints. Remember endpoints of each of the segments. And then we're going to project each of these curves. So I'm going to bring S into the G component of the projection tool right here. See, it's already projecting it, right? But it's projecting everything onto the base plane of the model space. We want to project these points to the lowest point on the actual slope itself. So actually, yeah, you know what I mean. So P right here, this plane, that is going to be one of the endpoints, whether it's a start point, end point. That's actually really doesn't matter. Let's just do end and see what happens. And so that basically allows us to take this point here and it projects it to, in this case, this point right there. And now we have a line that represents the horizontal length of it. If I change the projection plane from the end point to maybe the start point, like I do here, now it's doing something like this, which makes a little bit more sense visually. It's nice to see the triangle look like a triangle where it's going uphill. So this is kind of what we're doing here. So now that line there, that projected line is flat. That line, if I move to the right, you can extract a length. So if I type in length in there, there's a thing called length, measure the length of a curve, right? So now that curve here this projected curve, if we extract the length of it, we now have the horizontal length of each of those curves projected. Whereas over run, we got the run, we got it. Now we need the rise. So how do we get the rise? Well, the rise is simply taking the other point, right? And connecting a line from that other point to the endpoint of the projected curve, right? So endpoints, right? And we're going to take this endpoints tool here and we're going to connect it to that projected curve right there. So now we got the endpoints of the projected curve. So now all we need to do is we need to draw a line between the endpoint of the original curve and the endpoint of the projected curve. And so there's a tool in Grasshopper called line. Right here, create a line between 2 points. You see, Grasshopper literally just has a component for everything, and all the hundreds of components. You just gotta like get addicted to Grasshopper, and you'll eventually just like mess with each of these tools one by one. So line right here, what we're gonna do is we're gonna connect the endpoint of line 1 to the endpoint of line 2. Triangle. And now you get the length of this curve, length of that curve. And now you get the rise. So now all you need to do is you need to take rise and divide it by the run. And you see how like nice this script has kind of like eventually come out. The rise is over the run. It makes sense logically. And that's what, if you can have, again, as I said before, if you can have your script kind of laid out in a way that is logical, that is always the best way to go. So what we're going to do now is we're going to use a division component, division. So division, and that's what's right here, mathematical division. Right. So now all we need to do is do rise over run. Wow. And now if you plug in a panel into this result here, you get percentages, right? Percentages are always decimal numbers, but you get what I'm saying. These are percentages. So now all we need to do is we just need to find some way to visualize this on that line that we've drawn. So what we're going to do now is we're going to extract a point along this line, where the label for the slope can sit on. And so there's a tool called, or a component called point on curve. And the reason it's called point on curve is because you can create a point on curve. That was my smart Alec comment. So what we're going to do is we're going to use this tool and we're going to get a point on each segment. So I have to go backwards in time to this component right here, the explode component. This is where the curve got divided into segments. So we're going to take that S component right there, kind of bring it into this right there. And now this little tool here allows you to extract some kind of point along the length of that line. And it's extracting a length based off of what's known as a parameter, basically a number between 0 and 1 that represents the overall extents of that line. So let's just kind of put it somewhere near the middle, like so. This is going to be the location of the label. And now what we're going to do is, let me move to the right a bit, is we're going to use that text tag again. So text tag. And we're going to use this point right here as a location of the tag. And then we're going to format this value here. So what I'm going to do first to make the format a little bit nicer for our use is that we need to take this number here. We need to multiply it. So I'm going to type in multiplication multiply that number by 100 so that we can get our percentage without that decimal points. So I'm bringing up multiply component here, and then instead of like putting a panel into the B to put it 100, you can also just right click on the variable, in this case, the B variable, and just go to the set data item menu item here. And then in this line here, just type in 100, then type in commit. And now if I plug in a panel here, you see that, let me put 2 panels in fact, to compare the two. It went from, you see the numbers, let me zoom in slowly. You see that those numbers, these slopes now have been multiplied by 100. So now these are basically, you know, just numbers that you can put on a documentation set, because it's 19, 10, 21%. So now delete those guys. We're going to type in that format component. Now we're going to plug that number into the 0, right? Because we're going to format this number. And now we're going to create a little formatting definition. So let's do bracket 0 colon 0.0, because we only need to have 1 decimal point, I think, for slopes. Sometimes you get 2, but you don't really need that much precision. And then we're going to put a little percentage sign like so. And that goes into F. And then that now is formatted. So now we can plug it into T. And then just right click on this tag here and make it like a large number. And then what we'll do is also, you know, this component here, this point here, you can see it's kind of like making it's kind of like overlapping with the numbers. So you can just turn that off. So just click on that, preview off. And then, you know, like I said before, like a little trick you can do, you know, like this number is just sitting on top of that line. If you wanted to maybe offset it a little bit, you can just go in here and, you know, you can either put some spaces to the left of it, you can just put some spaces to the right of it. It doesn't really matter. Let's just do that. You can see it just begins to move it over a little bit. So you can make it just kind of like sit next to the line a little bit nicer, like so. Made it one more space maybe. So if I turn off preview in Grasshopper, you see in Rhino, literally you did nothing. All you did was just draw 4 points. But in Rhino now you have a visual now of your slopes. And what you can do is you can combine scripts. So let's take this guy here, let's move it down. And I can take this component here, you can plug it into this one right here, then preview that on. So now you have a little tool that gives you slopes and spot elevations. And this what I just did here, this is how, you know, Grasshopper, the complexity in Grasshopper is built. It's not one giant script that you write all together. It's a lot of little scripts that you kind of combine eventually. Like you can't conceptualize this all together at once, but you can conceptualize this in chunks. And so that's why whenever, you know, you look at Grasshopper scripts and they're so huge and long and crazy, and you go, what the, how did the person come up with, like, what the person who wrote the script was coming up with it in like chunks, right? They came with one little section, and then just connected everything together. And then they created these little tools or functions that allow them to do specific things. So congratulations, you've written now, you know, 3 scripts that, you know, you can use for your work. Heck, you even take this script here, you know, the length script, and maybe let's get the length of that line there. So, you know, that line was this line right here, right? So you can plug that into this like so. Actually, the area one doesn't count, so we'll just move that out of the way and just turn that off, preview off, or disable, preview on. So now you can see basically, and it's not projecting to that plane, so whatever, you know. Anyway, let me turn that off for now. So it's 9:05. We're gonna take a 10-minute break. So we'll be back at 9:15. Then we'll continue with one little variation of this. So let's return at 9:15. All right. Thanks, everyone. Okay. So what we're gonna do now is I'm gonna take this point script here, and we're gonna do something I think that will be very handy for most of you guys, and something that I use regularly in my work, which is to be able to create paths in Grasshopper that you can adjust and manipulate and cut contours from. So last semester in my studio, you remember I gave you guys a little script that allows you to draw a line and basically model a path from that. I'm going to write a variation of that for today, but it has a little bit more flexibility, and it's actually a little bit easier to use. So what I'm going to do is I'm going to take this point and this polyline component. I'm going to copy and paste it like so. Let me turn this off. I'm going to turn off all the preview for this one as well. And if you want to follow along, let me just explain what's going on right here. So let me zoom into this. Basically, we have a point component. And so in Rhino, I'm just gonna have like a bunch of points. In this case, I'd have 8 points, like so. And we're gonna set those 8 points into a point component in Grasshopper. Then we're gonna use a polyline component to connect these all together. And you can see basically I've kind of set these points at different elevations so that it's a path that kind of like, let's imagine it kind of going across a sloping terrain, right? So I want to take this here, and I'm going to show you 2 ways you can take this and turn this into a path. So the first thing that we're going to do is that typically, and usually with landscape architecture projects and paths, we like to have the turns of the path be a little bit more gentle and not so angular and sharp and aggressive. It just feels more natural to the human experience to have curves in the sides of this. So we're going to use a fillet component on this polyline tool right here to kind of add that nice curvilinear geometry to this. So in Grasshopper, double click into the space here and type in fillet. Actually, when I do that, let me type in fillet one more time. You see that there's actually a few fillet components right here. There's fillet by an angle. There's fillet by parameter. I'm going to choose this one, fillet by distance. I delete this one right here. Also, quick aside, I forgot to mention this. You'll notice that now the components look a little bit different. The picture on it is gone now. Basically what I did was I went into this display here, and you can either render the component with the icon of the component, or you can render it with the name itself. And so I changed it back to this. This might make it a little bit easier for you guys to follow along. So now you know this is the fillet command. So if you're following along and like what tool they use, you just read it. You have to turn your head to the side to read it, but there it is. Okay, so I'm going to take this line here and we're going to plug it into the curve to fillet. And then you need to add a distance. So basically what it's going to do is it's going to measure a distance from that point in of the line, and it's going to fillet that curve to that distance. And so I'm going to add in a number slider. So let's do it, and let's do 20.0. So that adds a number slider like so that you can get a number there. And then let's add that there. So see what happens now. This number slider here takes that curve and it begins to soften the edge. It fillets the edge of it. So we're going to take that now. And in order to make a path, you need to take this line, you need to give it width. So the simplest tool to do that is the offset tool. And what I like to do is I like to offset it on either side of it. So instead of offsetting in one direction, I like to offset it in both directions. That way, this actual line here represents the center line of the path, which is a bit more of a useful metric and design tool to use to design path is to design it via the center line, as opposed to designing it via the left side or the right side of the path. So let's go here. Let's type in offset. And you see that there's this tool called offset curve. So if you plug the C into the C here, right? You see that the curve, let me zoom into Rhino space, offsets that curve. So what we're going to do is we're going to want to offset it by a specific distance. So what I'm going to do is a little bit of fancy math. Basically, let's say you wanted to create a 10-foot path. So I'm going to bring in a little panel right here. And I'll type in 10, right? If I plug in 10 in here, like so, it will create a 10-foot path and will offset it by 10 feet. But if I wanted to use this line here as the center line of the path, you actually need to offset it by half of 10, right? 5. You need to offset it by 5 on one side and 5 on the other side. So what we can do is this, is we can establish a overall dimension, that being 10 of the width of it. But in order to offset it, we need to basically take this and divide it in half, right? So we're gonna use a division component, right? Division right here. And we're gonna plug that division in here, 10 into A. Then B, we're gonna set that to be 2. Right, so I'm just gonna use the set data item component right here. And then that way we get the halved value of the path width. This is a little bit nicer way to set a path width as opposed to saying like 5. Now you can just literally set in your head, like, I know it's going to be 10 feet. Maybe you want to make it 11 feet, you know, and then the offset value is 5.5. It just makes it a little bit more convenient of a way to offset it. So then what we're going to do is we're going to plug that into the D, right? It's like so. And then we're going to need to offset it in the other direction, right? So we're going to copy and paste this offset. So I'm going to Control C, Control V on my keyboard, and that just copies that component like so. And then what we do is we need to take this offset value here and we need to give it a negative value. So we're going to type in negative. And then we could take this value here and we can basically make it a negative number. So now we get negative, in this case, 5.5. So this now goes into that component right there. So if I spread this component out a little bit, you see basically what we've done. So we set the path width, divide it in half, and then offset it by 5.5 in one direction and negative 5.5 in another direction. Now we basically created a simple path. And again, you can go back to the model here and you can adjust the points and you can adjust this fillet here to adjust the curvature of it like so. And of course, this path is in 3D so that, you know, if you adjust the spot elevation of say one of the paths, let's say we move, you know, this down a bit, you know, it still changes that. And so that's a nice way you can easily model a path. This is, though, with that being said, this is not a surface yet. This is just 2 curves, right? I'm gonna do this. I'm gonna take all these here. I'm just gonna turn off the preview so you just see the outline of the result. So what we're gonna do is we're gonna take these 2 curves here and we're gonna turn it into a surface, and the tool to do that is Loft. So I'm gonna double click in Grasshopper and type in Loft. And so Loft, basically you can select a bunch of section curves in this case, or just a bunch of curves, and just basically interpolate a surface in between the 2, right? So what I'm gonna do is I'm gonna first choose this curve here, bring it into the first C there. And then if I bring the second one in there, you see it kind of replaces it like so. It doesn't allow you to put 2 in the 2 at once. You have to hold shift on your keyboard. And you see now it allows you to add additional wire into the C. So if you want to add multiple inputs into one component, you need to hold the shift keyboard on the shift button on your keyboard to do that. And now you've created essentially that surface. If I turn on the this button right here, which turns on the shader view. You can see now you've created that surface, right, like so. And then what's nice to do, obviously, is to take, you know, this point component right here and utilize this here, right? So let's plug in these points into that right there. And then that allows you to visualize the spot elevations of the vertices and also the slopes of the segments, though it's not exactly correct. This is visualizing the slopes of the entire length of it as opposed to the actual curve. So to fix that, basically what we need to do is we need to take this line here, right? Or rather this filleted line right there. And we need to explode that and then use replace it with this right here. So basically what we'll do is let me do, all you need to basically do is this. Take this fillet right here and plug it into C right there. And then that is, as you can see, makes it so that you see the slopes of the curved portions of the walk in addition to the linear portions. I feel like that part I just explained might have been a little bit too confusing, but hopefully that makes sense. Basically, well, I'll just leave it at that. It's better not to over-explain things, but basically, this tool now allows you to draw a path, you know, and visualize a path, adjust the curvature of it, and also be able to visualize the slope of it. And then what you can do is
tweaking and tinkering with them.
Sorry, repeat the question.
I was just saying, like, a lot of those commands that you just showed us how to do, like fillet and offset and things, are things you could just run in Rhino. But the benefit of doing them in Grasshopper is that you can keep, like you're doing right now, like tweaking them.
Correct.
And manipulating them in real time.
Correct.
Okay.
What you're describing, Sadie, is what I believe to be the aha moment in Grasshopper, which is to say that once you've mastered the concept of using scripting, Grasshopper makes modeling almost feel like hand drawing, because you can just literally intuitively begin to like move and tweak things, which is a very analog style of working, right? You just work by feel, right? As opposed to drawing the line, offsetting, drawing the line off, you know what I mean? And this feel, like just like tweaking and adjusting things, just making it look right, is a very intuitive way of working. And so the moment I learned how to master Grasshopper and the moment I began to work this way, I realized that Grasshopper, in my opinion, is the digital version of drawing by hand, which completely seems counterintuitive. You look at Grasshopper and you see all the wires on the side, think, how is this anything like hand drawing? The feel of it, the mental feel of it, once you've mastered this, feels exactly like opening a sketchbook and drawing, because you just like look at this and go, you know, I want my path to be like that. I want my path to be like that. And that's why, you know, this is a tool that if you really get into, I think you'll find it very rewarding, because it just gives you that natural feel. So the last thing that we're going to do is we're going to take this surface here and we're going to cut contours from that. So there is a tool in a component called contour. Actually, let me do this. One thing you can do is, I know I'm scrolling around and you guys don't like that. Let me disconnect this for now. Move this out of the way. I'm gonna do a little bit of cleanup first. Sorry, bear with me for a second. I know it's confusing. I'm gonna take this. So this whole script up here, you see this, that visualizes the slopes. I'm gonna do this. There's a little thing you can do in Grasshopper is you can right click on any input parameter, and then the wire display, you can set that to be hidden, like so. That basically takes that wire that's connecting it to this and just makes it invisible, so you don't see it. It's still running in the background, but it's invisible. The reason I'm doing that is so that I can just focus on this portion of the script, and it doesn't have all the wires overlapping with another and just looks confusing, right? So this, I just want to make it so that's a cleaner interface. That this is the script this is the path script that I want you guys to focus on. Is just a very simple offset. Okay, back to the tutorial. So we're going to do a contour. So type in contour, and you see that there is this contour. Create a set of B-rep or mesh contours. That's what we're going to use. There's also a curve contour. That's not the one we want. We want to use this one right here. And then what you can do is you can take this surface right here. You can plug that into the S, which is asking for the surface to cut contours from. It's asking for a starting point and automatically defaults to a 0, 0, 0 starting point, which is good. That just basically means it's starting from the 0 origin. It's going to ask for a normal direction, and it always defaults to the vertical normal. Basically, when it says 0, 0, 1, that means it's the vertical Z direction. And then the last thing that we need to put is a distance between the contours. So I'm going to bring in a little component on the side here, and we're putting a 1 for a 1 foot contour and plug it into D. Then you see what has happened now in Grasshopper is that, let me turn this preview off here, is that now that path now has contour lines drawn along it. So this is one thing I sometimes do is I like to, just model the path abstractly using a basic center line, and then set that onto the landscape, and then just have the Grasshopper tool cut contours from that. And then I just simply take these graded path lines and connect it back to existing grade. And that's a very simple way that you can, grade a walk in Grasshopper. I'm going to open up to any questions right now. Does anyone here have a smart question? And actually, I'm not kidding. I want you guys to think back to your grading studies. Like I've shown you this grading path here, and there's something missing. Does anyone have a smart question?
Is there a Grasshopper script that will just connect it to the contours for you?
That wasn't the question I was hoping for, but I'll save that for another lecture next week. Yes, how to connect this back to existing grade. I'll save that for another lecture. That's a good question.
Is there a way to constrain this to ADA requirements where it keeps it beneath a certain slope or adds landings or whatever?
That's a very good question, but not the question I was hoping for. These are all good questions. Sorry, I was saying the way to constrain ADA is you just got to use this slope tool here just to make sure that all the slopes here are ADA. That to me, ADA is a design parameter. You just got to look at the slopes that you're designing with and making sure that's not exceeding 5%.
Well, I think he's kind of getting at a greater question, which is when typically people do 3D modeling, like for animation or for industrial design, they have parent-child relationships where you put parameters on the things you're constructing so that they just can't do certain things, like they can't bend one direction, or they can't, like a hinge can only turn one direction. Is there an equivalent to that in Grasshopper where you kind of limit where you're even able to move the gumball of something?
The answer to that question is I'm not sure. And I actually don't think it's, if you ask me, necessary to do that. This is where the designer intuition comes into play. What you're asking for is for Grasshopper to have built-in intuition, built-in knowledge of what makes sense, which is way too complicated of an ask for Grasshopper to fulfill. In my opinion, Grasshopper just needs to take care of 50% of the work, and then your intuition takes care of the rest of the 50. So yes, in my opinion, the best way to deal with that question is to look at the data that you're given here and just say, okay, well, at 6%, we just need to adjust the design to make it, less than 5%. It's a bit more of an intuitive way to work, as opposed to just writing a long script that forces the whole thing. That's just, you understand, like building intuition into a Grasshopper script creates a really complicated script. You know, save that for your own head.
Can you add spot elevations along the path?
Yes, you can. That's as simple as simply getting points along the path and then using the spot elevation tool that I just showed you.
Or can you add I guess this would solve the problem of the curve dimensioning that I was saying earlier. Can you put like XY locations?
Absolutely. The answer to that question is very simply just going back to this initial, well, it was this one right here. Yeah, this one right here. This initial component here that allowed you to visualize the spot elevation. You just need to format it to visualize X, Y, and Z.
What do you want us to ask Frank?
All right, sorry. I've been leading you on, and I feel like I wasted like 5 minutes of your guys' time. You need to add a cross slope onto the path. You need to water the drain on it. Right now there is no cross slope on this. The water is just simply just following the path itself, and that's why I was hoping that the grading knowledge that hopefully you guys learned would have come to play, is that every path that you design in almost every design needs a cross slope. Water needs to shed off it. So here's how we do that. I'm sorry, guys. I'm not a good teacher, as you can tell, because I ask leading questions that waste time. My teaching career is likely over at this rate. So what we're going to do is we're going to take one of these sides here. We just need to move it. We just need to move it down, right? Move it in a vertical direction to basically build in that cross slope. So what we're going to do is we're going to take one of these curves here. Let's take this one, for instance, type in move, right? Move an object along a vector. Let's move this out of the way first. We're going to move this one along a vector. We're going to move it along a Z vector. We want to move it vertically. So I'm going to double click, type in Z on my keyboard, and you see this unit Z vector, like so. I'm going to plug that in into that, like so. And right now it's moving it in the vertical direction, one foot. It always defaults to 1. But we want to move it in the Z vector direction in a unit that is, let's say, a 2% cross slope along this 11-foot width path. So we want to take this number right here, this 11-foot width. I want to multiply that by the cross slope percentage, 0.02, right? 0.02% is the typical maximum cross slope for our walk. So we do that, plug that in here, and now we got a vertical change number that we can use. Actually, we're gonna do this. We're gonna do -0.2 because we want to move it down. So that number goes into here. So now that side here has moved down a dimension that creates a 2% cross slope. So now this curve here is the curve that we loft with that upper curve, which we didn't move at all. So this goes here, hold shift, move that in there. And now you have a adequately, appropriately graded walk, where now it has the walk, but it has a cross slope associated with it. All right, that was my teaching moment for you all. You guys don't care about cross slopes. I know you're probably just gonna, design your parks and your projects with just like water that just drains on the path itself, because we don't ever talk about that in reviews. We don't get to that level of detail. We just look at the design and just think, oh, did you consider this? Did you consider that? Well, Did you consider the cross slopes? I guess not. All right. There's 10 minutes left in the class. What I want to do is one last thing, and then we'll end the class, and then I'll let you guys go, and then we'll have, what I'll do is over the course of the spring break, I will continue to share a few more tutorials, and I want to share also a few designers that I want you to get inspired by and look at the work. I'm going to show you guys a more advanced way of creating a path, but a way to create paths that I think is a lot more intuitive. So let's go back into the script here. And what we're going to do is we're going to take this portion of the script. I'm going to copy and paste it, move it down like so. Take this portion here. We're just going to turn it off. What I'm going to do is we're going to create a script that allows us to draw. I'm going to go into the top view first, draw our own path section, right? So let's say you want to draw like a 10-foot path, right? I just drew a line here. We're drawing right now is basically a section, and maybe you want that section to have a swale, right, with it. And maybe you want that section to have like a berm next to it, right? And I'm just drawing them as angular geometry for now. But this is a path. This is a section. A person stands on here, is walking along the path, whatever. Can you take this line here and can you actually make that part of the model? And you can. And this is what one thing about Grasshopper that I love is that you can design intuitively. Like I said, you can design a section of your design, and you can also design the nature of the path itself, and you can combine the two together in a very intuitive way. So we're going to take this section that I just drew right here. Not even a great section, like literally, like it should have some nice, like softer edges here. But we're going to take this and we're going to make this part of the design. So what we're going to do is we're going to take this section that I just drew here, and we're going to add it. Let me zoom into Grasshopper. We're going to take a curve component, right click on that, and set that section as a curve component in Grasshopper. This is being drawn in the top view right here, right now, just like we're looking down in the model, the top view. I'm also going to add a point on the midpoint of the walk of this section here. This point is basically going to be the plane that allows us to align this section to the walk that we just drew. So I'm going to also set this point. So I'm going to create a point component in Grasshopper, set one point. So now we have a curve, the section, and a point that represents a location. I'll come back to this in a second. So back to this path here, right? This path. So what we want to do is we want to take that section and we want to move it onto this path in regular intervals so that we can basically loft one path across this whole thing. And so what we want to do is we want to basically segment this path into a series of planes that we can attach this section to. So there's a tool in Grasshopper called divide, I think what's called frames, I believe. Yeah, right here. Perp frames, perpendicular frames. So if I take any curve in Grasshopper, you plug that into the perpendicular frame component, it basically extracts a plane along that line. And right now it's dividing it into 10 frames, takes 10 segments. So I'm going to create a number slider. Let's type in 100 number slider, and let's add a bunch of frames. You can adjust this number here and see if I slide around, adjust the number of frames. And we want to attach that section to this frame here. Now, before I do anything, one thing to keep in mind, if I zoom into this frame here, you see how the frame has this darker red line and this green line right here. This represents the orientation of the frame. And we want to make sure this orientation, this frame orientation, matches the frame orientation of this section here. So this section here, if I zoom out, if I move it closer to the origin of Rhino, you see Rhino also has a green line and a red line, right? The green line is pointing up and the red line is pointing to the right. So this orientation, if we set it, in the way it currently is, would create an upside down section. So we need to adjust these frames to match that. So in Grasshopper, what I'm going to do is I'm going to use a component called align plane. Right here, align plane. And what that allows us to do is take each of these frames and align it to a guide vector. In this case, we're going to align it to the vertical vector, which is the Z direction. So I'm going to type in Z. And then what happened is basically we turn this off, preview off of this right here. The orientation of the frame has now been aligned. It's been rotated. It's still not quite correct. You can see that the green line is still pointing into the to the right, like so, as opposed to being pointing up. So what we're going to do is we're going to rotate this plane. So we aligned it so that everything now has a vertical orientation. But now we're going to rotate it so that the green line is pointing up. So there's a component called rotate plane. So that gets plugged into P, like so. And then in the angle right here, everything in Grasshopper in terms of rotations is always in radians, which is a little bit of an annoying thing, but just something you gotta get used to. So this angle here needs to be 90 degrees. So here's how you do that. Basically, you bring in a panel that's put in 90 for 90 degrees. Then you need to convert this 90 degree into a radian number. So type in radians. Then if you plug the radian value of that in here, now it rotated, and then you can see it rotated in the opposite direction. So actually what we should do is we should rotate it by -90. There we go. So now these planes are orientated correctly. So now we can take these section curves right here, and we can now project them onto each of these planes. So there's a tool called Orient. Orient allows you to take any object and its associated plane and project it to a new plane. So basically we're taking each of these sections and we're using this reference plane here, and then we're moving it to this plane here. So G is going to represent the initial section. A represents the initial plane, which is this point command right here. Then B represents the final plane, which is this one right here. So let's turn off the preview for all this stuff here. And you see what has happened is now we've taken, let me do this actually. Let's decide. Let's do this and move this down like so. So you can see kind of everything at once. We now have a section that's now projected onto the path with the profile that we drew here. And again, you can adjust the shape of the section, or sorry, the path itself, and the profiles adjust with it. And then the last step is to take all these profile sections and turn that into geometry. So what we're going to do is we're going to take all these sections here, use the Loft command, Loft, then just loft all these surfaces together. So let's turn off the preview of these sections, like so. And then you can basically see now that we've created a path that matches this really bad section that I drew. And Parametric design, you know where I'm going with this. You can adjust the section and it dynamically changes the design of the path as you work with it. So let's say, for instance, you know, you want to add a cross slope. So what you do is you take, you know, that portion there, you move it up to add that little cross slope right there on the path. So now it's very subtle, but it's there. You can go in here, you can fill it, fill at the corners of these. Let's say, for instance, a swell right here, let's fill at the corner of that, fill at the corner of that, fill at the corner of that, maybe fill at the corner of this. So you see now the path is now beginning to have a bit more of a smoother look to that because we've smoothed it out. And of course, you can take this surface here, you can contour it. So remember, when we put in the contour, we want to put the surface in. It automatically puts in the base contour as 0, 0, 0. Automatically puts the Z vector as a contour vector. And D here, this just needs to be set to the interval, in this case, 1. And there you go. So now you can see basically this section. Actually, let me do this. Let me show you another trick. Basically, you know, you can see that everything's like red, right? And that makes it so it's kind of hard to distinguish some elements from other elements. You can use this tool called custom preview right here, custom preview. Then allows you to take any piece of geometry and render it with a different color. So instead of using it like this red here, let's take the surface and render that with just a simple gray color. So if you type in swatch, you can bring up a color swatch. Then you can render, say, the surface as a white material, or in this case, let's render it as like kind of a mid-gray material. And then you can take this tool here, copy and paste it, and then render the contours with, say, for instance, a black line. And so that just allows you to, let me turn off the preview for the actual base geometry. That allows you to render the design of it in a little bit more of a legible space. So again, you know, now what you can do is you can go back into the section here, and if you want to adjust it, let's say you want to make this mound less intense, you can do that, or you might make it more intense, you can like move it vertically up. And you can see basically that allows you to create that path. And you can even see that there's the cross slope that we kind of faked in this section here. But again, this is kind of go back to my point earlier, which is you want to be able to design intuitively. You want to be able to just come up with ideas and let the documentation and the representation of design just come as a result of that. And that's why Grasshopper, again, once you get into it and once you understand what it's about, it is literally designing like you're sketching by hand, because you can just come up with ideas and not worry about grading. So, you know, like, you know, Studio Chattanooga, I know you guys were working on your grading plans, you know, last week or so. And if you ask me, like moving contours, it's such a mind-numbing process. It's not fun, but you just want to have fun when you're designing. You just want to come up with ideas and just let the grading be a result of the concept. And this is hopefully one of you or two of you will get inspired by what I'm saying, and you'll get it. I've taught Grasshopper many times in my past, and I said like 0 students ever get it. So hopefully one of you will get it. But trust me, buy into this thinking here, which is you got to work efficiently, and you got to find a way to make design the first thing that comes in your brain, not the documentation and the contouring of it and all that stuff that makes design less fun. So something like this allows you to get to that point. Again, you can adjust a section, do anything you want with it, you know, take the edge of the swell, you know, adjust, you know, portion of it, and the grading of it just comes naturally from that process. So if you follow along today, great. if you did not follow along, I encourage you guys to, after, you get through your reviews, try to follow along this tutorial at your own time and get addicted to Grasshopper. What I mean by that is like, just get used to the whole process of like moving in the interface and understanding the potential of it. And then next week and the week after, we're going to do a few more tutorials that begin to like expand that field of Grasshopper, where you can start creating like textures and patterns and crazy cool things that you've seen out there in the world. And we'll get to that, but you got to start at this basic point right here of just like understanding how to do simple stuff like this. Okay. Any questions about this? Otherwise, I want you guys to get out of here. Any questions? Hopefully this is exciting. Hopefully guys, you will share with my enthusiasm of this tool and not treat this tool as just another thing you got to learn how to do. What I'm gonna do now, we'll wrap about 5 minutes. I'm gonna do this first. I want to bring up the box folder. So in the project brief, I put in the project 3 right here. So this is the project that you're going to work towards. You can read this in your own time. The due date for this is going to be March 22nd. So we're about, a few weeks away from that. And so basically in the next few weeks, you're going to learn how to use Grasshopper, and you're going to be able to create patterns and images from that. And the whole point of this assignment is that I want you guys to learn how to use Grasshopper and create some very basic patterns from that. And so in the tutorials to come in the next few weeks, we'll get more into the whole patterning and that aspect of it. But the first step before you even get to this point is just know how to open Grasshopper, just know how to like put components onto a space, and just know like it's about creating these parametric connections and things like that. But in case you're wondering what the next project is, it's this one right here, and you can read that on your own time. The next thing I wanted to do was I wanted to talk about a few resources that you can look at, and I'll share these resources on my recap email later. But there is a designer that I really hope you guys look into. I've never met him before, but I've been inspired by this guy named Andrew Human. Andrew Human right here. Maybe I'll just copy and paste his name into the chat box right here. Andrew Human, he's an architect, and he does a lot of these computational drawings. And believe it or not, everything you see here is all done in Grasshopper. And he's managed to take the whole scripting component of Grasshopper and actually use it to create art. He's a designer. He trained as an architect, but he has created these really amazing visuals. And that kind of shows what I want to kind of point out is that Grasshopper is not just creating, the parametric looking pavilions and tree structures and stuff like that you see in architecture school. It's actually also just a tool you can use to create things that you can't imagine, but the tool allows you to create. So I encourage everyone here to check out this guy's website, Andrew Human. And then the last precedent I want you guys to look at is this thing called Hopper. Let me actually do this. Yeah, this one right here. This was a class that was taught. Paste into Instagram, into the chat. Class I was taught at WashU, and again, another example of the kind of work that I'm hoping we can arrive at this class. Again, taking Grasshopper and creating some very fun visual patterns, not really specific to sites or specific to anything. It's just creating cool visuals. And for anyone who's just learning how to use Grasshopper, this is a great place to start. It's just creating very simple visuals of patterns. So we'll get to this point in the semester. Okay, so those two precedents. The last thing, I know I keep saying the last thing. This is actually the last thing, is I'm grading your assignments from project 1 and 2 right now. I'm about halfway through. I will finish those grades, and I'll make sure that you guys get your midterm grades sometime before spring break, but most of you should be okay. Don't be surprised if some of you get surprisingly low grades. Like right now, I'm kind of averaging like a C, B in the assignment grading right now. And honestly, you probably expected that at this point, but that is kind of my average for the class so far. So, but that's happening right now as we speak. So expect your grades shortly. Any questions? Otherwise, I'm gonna let you guys go because you guys got to get to Camp Hill or whatever you guys got to do. Camp Hill. Oh boy. Okay. Thank you all. I love Camp Hill. Camp Hill is great. I think Emily Knox's farm is great. Again, because it's all recorded and I don't want to sound like I'm dissing Camp Hill. Okay. Thanks everyone. I'll catch you guys around and some of you I'll see you in review later this week. All right. See you guys. Bye.